Hello class, I hope everyone is doing great when they start watching this video. Today we're going to start talking about thermal energy and kind of the basics of it, how it all works, what's the difference between heat, kinetic energy, thermal energy, and temperature, and just try to get a better idea of exactly what these concepts really are, what these words really mean, and what we're really measuring. So, with that, we always have some questions. So why is our question? So what is energy? What is energy? When you guys think of the word energy, what comes to mind? Maybe for you, energy means to be active, right? So when I think of energy, I think of someone who maybe talks really fast, someone who's running around a lot, someone that has a lot of energy. But energy can be a lot of different things, lots of different things. Another thing to think about is how is energy moved from one object to another? So does it just randomly spread, or are there certain ways in which you have seen energy move or can think about energy going from one object to another? So our objectives by the end of the day is we want to be able to describe kinetic energy, thermal energy, temperature, and heat, and then be able to give some examples of thermal energy. So we have a great video. I always think it's great to watch some of these videos to get us starting to think about it and see some illustrations in a different way and hear a different explanation. So please pause this video and watch that one. I think it does a really good job. The next thing we're going to do is this definition activity. So after watching our video, they had some good definitions. So we want to go in here and match the correct definition and picture all together. So this is something that I'll let you guys do, but I just wanted to show you it and what it looks like. So there are 3 different columns and 4 different rows. So the idea is you could take something like kinetic energy, whatever definition you think it is. So I'm just going to grab this one and then put the picture you want right here as well for what kinetic energy might look like. So there are no right or wrong answers. I just want you guys, well, there is right or wrong answers, but I just want you guys to do your best that you can. Arrange these in the right column and order. So our second one would look like here. We would put a sticky note, a picture, and a term all in the same line. So that's the idea. But whatever you guys think is best, whatever you guys can remember from the video, or maybe from just using some good deciphering ideas or tactics, strategies for process of elimination. So after that, we're going to go through and talk about kinetic energy. So our kinetic energy is the movement of particles in an object. So that is our definition. We have gases, have more energy than liquids. So we saw in our simulation about phases that as we increase the temperature, our things would change from liquid to gas, and then everything would start moving more. So our objects inside would move a lot more. So gases have more kinetic energy, I should be more specific, than liquids. Liquids have more kinetic energy than solids, and then we have a simulation. So we'll show another one. This one's a little bit, this is the same one. So, oh no, this one's a little bit different. So how does we're going to look at how it changes from phase to phase. So if we're talking about, let's go to argon this time. Let's look at, right now it's in a solid form. If I no, that's going to keep it in a solid form, sorry. So as I raise the temperature here, as I make it go hotter and hotter, we're going to go from a solid to a liquid, from a solid to a liquid. And we can now see that our elements, our molecules, I should say, are moving faster around. And if we bring our pressure back down, if we just bring the pressure down more and more and more, let's keep going. that our pressure increases so much that it says it breaks the whole lid. So our gases were hitting each other so quickly that they broke the lid. Let's see another one. Let's make it cold. So as we make it colder, what water looked like it was in a gas form, if we go down, it's going to come back into a solid. As we increase the pressure now, it's going to actually heat up because we have them hitting each other more. We have more kinetic energy now. They're moving more and more and more, and they're moving really fast until our lid blows. So, just kind of a fun simulation to show kinetic energy is all about the movement of particles. We have this short video about Bill Nye the Science Guy talking about thermal energy. So thermal energy, which is abbreviated as Q sometimes, is our total energy of all the particles in an object. So we can calculate this by finding using the equation Q equals mCp delta T. So we'll talk about this equation later, but just wanted to talk to you guys about it now. But what it means is our M stands for mass, our delta T stands for temperature. So our thermal energy is determined by temperature and mass, and then this C stands for a constant. So each different material has a constant associated with its thermal energy. So all that really changes is how much you have of it and the temperature it's at. So for example, as we heard in our video, a large cold object like a block of ice can have more thermal energy than a small hot object because the mass is much greater. So anytime we have a big mass but maybe a small T, we could have still a bigger Q than if we had a small mass and maybe a medium temperature or even a hot temperature. So if our mass is big enough, then something else, even though something is colder, it could have more thermal energy. So a good question to help clarify this is, what would have more thermal energy, a 10 kilogram block of ice or a very small fire? Well, the 10 kilogram block of ice, because our fire is so small that it doesn't have enough delta T to make a difference. So we're going to talk about temperatures now. So temperature is a measure of how hot or cold something is. So temperature is a measurement, I should say, and it is also the average kinetic energy of the particles moving. So when I think of temperature, I think of thermometers. So we use thermometers a lot. We have a digital one up here that you might have seen maybe walking in and out of stores during the pandemic. I've used this a lot, or seen this a lot. And we also have these other ones which use mercury, which is one of our elements on our periodic table. And one that uses mercury is very, very common, has been used for a long time. And as the mercury gets warmer or colder, it moves up or down. So as it warms up, it goes up the scale. As it gets colder, it goes down. We have a couple different units to measure our temperature in. We have Celsius, we have Fahrenheit, and we have Kelvin. So those are a little bit about temperature. Now a little bit about heat. So heat, we said, is the transfer of thermal energy from hot to cold objects. So our temperature is a measurement of our kinetic energy. Our heat is a transfer of our thermal energy. So they're a little bit different. When we think of heat, the important thing about heat is that it can be transferred, or it is the transfer of thermal energy. So there are three different ways it can be transferred. There's convection, which is transfers heat through a fluid, which is a fluid is either a gas or a liquid. So we can see this convection right here. We're having heat going from the bottom of this water to the top, kind of in a circle. So since it's moving through a liquid, it's convection. We have conduction, which is transfers from contact with another object. Our picture up here, I think, does a great job of showing conduction. So if we have a hot block and a cold block and we put them together, they both become just warm blocks. So our heat transfers by touching something else, which is conduction. or radiation, which is through electromagnetic radiation. So that happens a lot when heat is radiated, is a word I've heard used a lot. When we think, when we can feel something that is hot, like the sun or even human bodies, that is the radiation coming off them. So let's go through some thermal energy examples. So I'm sure you guys can think of lots of different things give off this thermal energy. Things that feel warm are usually giving off some kind of thermal energy. So that is some examples I thought of course, is the sun. The sun might be our best example of this. We also have a fire. So anytime we're standing around a fire, maybe we even have a match or just a small fire for cooking. That is an example of thermal energy. We have a cup of coffee gives off some energy, an oven, hair dryers, toasters, washing machines. So there's lots and lots of different examples of thermal energy. If you guys can think of any more, I would love to hear your ideas. Really, anything that gets hot or warm is an example of thermal energy. So just to check to make sure we have everything that we started, our objectives were how to describe kinetic thermal energy and temperature and heat. So when we talked about kinetic energy, it was the movement of particles. When we talked about thermal energy, we said, let's make sure we have our definitions. Thermal energy was the total energy of all particles in an object. Our temperature was a measurement of how hot or cold something is. And our heat is the transfer of thermal energy from hot to cold objects. And then what are some examples of thermal energy? Well, we just gave 7, I think, here. So lots of examples as well. That is all I have for you guys. If you guys have any questions, please let me know. And if you have any other examples or any other thoughts about thermal energy, I'd love to hear them. If not, I hope you guys have a great rest of your day.